Hi, I am Karel de Bond and I'm a business development manager at NetOnLive, which is a media production technology company based in Brussels, Belgium. We make LiveOS, a software platform for high-end live and recorded media production. LiveOS is a flexible, scalable, shareable and sustainable solution that runs on common off-the-shelf IT hardware and on a SMPTE 2110 video over IP network. With LiveOS you can perform local, remote and decentralized production, and operators will access the user interface of LiveOS via the web browser or by using programmable hardware panels. The use case that I'm going to talk about started with a sports production company coming to us because they saw an opportunity in the huge demand for low-cost live sports production. However, to turn this into a viable business and to make this happen, they had to lower the cost per production and they had to increase the volume of productions. For that, they were ready to innovate on their workflows, but they wanted to keep on working at the highest possible broadcast quality standards. Together with them, we developed a remote production workflow over the internet, and we built a flexible, easy to use and quick to deploy REMI box that allows you to do remote sports, but also news and entertainment production. The solution and the workflow is built around LiveOS and around the Matrox Monarch Edge SRT encoder and decoders, and the solution is actually being used today in the field. Now let's take a look at this workflow that we've built, starting with the three different locations. So you have the REMI box next to the soccer pitch or in the hockey stadium. You have LiveOS sitting in a data center, and you have a control room in the production office from which you will be running the production. Let's go from left to right. So we will start by connecting all the cameras and the microphones to the REMI box. We will embed the program out audio into an SDI stream, and all the SDI streams will go through the Matrox Monarch Edge encoder and will turn into SRT that will be tunneled through the VPN over the public internet all the way into the LiveOS infrastructure in the data center. On this LiveOS infrastructure, there will be running a LiveOS production that will be operated from the control room through the LiveOS user interface via programmable hardware panels and by looking at high-res monitors. Now, what we've actually done in LiveOS is we've virtualized functionality that is traditionally tucked away in dedicated hardware devices, and we've translated it into small software executables, which we call functional blocks, that will be running on LiveOS media servers in the data center. Each functional block has a corresponding widget that will be available in the user interface and by which the operator will manipulate the functional block. And then it's the operator's job to compile their own user interface layout by clicking the correct widgets on the screen. And you can see that in this photo where an operator builds up her own layout as a playlist operator and production assistant in such a way that she's able to perform her role in the production. You will have a program out that we will send to the archive, to the streaming infrastructure or to the MCR, but we will also send it back in SRT to the REMI box, where it will become an SDI out that goes to a screen so that camera operators and the on-site technical assistant can look at the program out or, for example, at a multi-viewer. We will also be able, over the internet, to control the devices that are inside the REMI box and that are connected to the REMI box. And we will be able to do that through the LiveOS user interface in the control room. For example, we will be able to move about and zoom in and out a Pentel zoom camera. We will be able to do shading on cameras. We will be able to send tele information, and we will even be able to control the integrated audio mixer from within the LiveOS user interface, where we will have a widget with faders that the operator can use to make a mix on the audio mixer. And then, of course, in every production, you need opening credits, you need metadata, rundown information, on-air graphics, and so on. These are either available online or on the company network, and they will be used in the LiveOS production in real time. What is inside this REMI box? Let's start from the top, where we have a VPN and a network switch. The network switch will be used to connect all the network devices, and all this traffic will be pushed through a VPN tunnel over the internet all the way to the LiveOS infrastructure. One row lower, we have the SRT encoders and decoders, which will give us 4 SDI ins and 4 SDI outs. We have an audio monitor to which we can send SDI streams and listen. And then we have an audio mixer inside the REMI box. It is there for 2 reasons. First, to be able to make a direct mix for on-site commentary or hosting, to avoid the delay effect that sometimes can occur in remote production. Secondly, it is there to make the program out audio mix. So through the LiveOS user interface in the production office control room, we will be able to make a mix on this remote machine and then embed it in the SDI, send it over SRT to the LiveOS infrastructure and use it as the program out audio. We have an SDI router and a video monitor, so we can look at all the locally connected sources, but also at what is coming back over SRT. And on the back plane, we have all the required connectivity. Some of the benefits of working like this, as you can see in this picture already, it's a very compact, small form factor box. You can set it up very quickly and it's easy to transport and it fits in the back of your car. The on-site team can be reduced to the camera operators and a technical assistant that will connect all the cameras and the microphones and the internet. And depending on the LiveOS production that is running in the back end, you can do sports production with this setup, but also remote studio production or any other type of production. And once again, thanks to this VPN, connecting the box to the internet becomes a very easy task, and the VPN will take care of all the network traffic and all the SRT streams finding their way over the public internet all the way to the LiveOS infrastructure. We decided to work with Matrox Monarch Edge SRT devices because they have some characteristics that come in very handy in this type of workflow. For example, they have very low latency, all the way down to 100 milliseconds glass to glass. You can plug in a 1080i source, which is still widely used at broadcasters here in Europe, but of course you can also do 1080p, either in 50 or in 60 Hz. You can gen-lock the SDI streams at the decoder side so that they're immediately in sync with the local infrastructure. And the devices have an API. This API has allowed us to control the Matrox devices from within the LiveOS user interface. So you don't have to log in into each SRT device and tweak the parameters. No, you can stay within the LiveOS user interface and control everything from there thanks to this API integration. Inside the SRT boxes, there is an H.264 hardware encoding available, which not only gives you beautiful 42 10-bit images, but which also helps to keep the latency low. And then if you start stacking multiple Matrox Monarch Edge devices to one another, you can create SRT streams that can contain 8 SDIs or even 12 synchronized SDIs and so on. They are upgradable and soon available in SMPTE 2110. So on the back end of these devices, there are 2 SFP Plus cages that will take in and out SMPTE 2110 traffic, and that will provide also 2022-7 redundancy. And then some typical settings for sports that we landed on, depending on the desired quality and the available internet, is for an individual video stream, we would recommend to go towards 25 megabits per second if your internet allows. If you have to go down, we would recommend not to go lower than 7.5 if you want to keep nice and clean images. Same with the fixed delay. If you have good internet, you can go all the way down to 100 milliseconds. If it's a bit more rough, we would recommend to pull it up to 1 second of delay. Let's go back to this initial schematic where we have the REMI box next to the soccer pitch. We have LiveOS running in a data center, and we have a control room from where the production will be operated. How do you scale this so that you can do a higher volume of productions? Well, let's take a look at this LiveOS in the data center, which is actually a bunch of LiveOS media servers on which the audio and video processing is taking place, and they represent themselves as a pool of available processing power, to which you will be connecting REMI box and control room that we already discussed, but also a second REMI box, a pop-up control room in the production office, maybe an on-prem studio, and a remote connected operator working from home. Thanks to the resource management in LiveOS, you will be able to spin up simultaneous productions. As long as you have available bandwidth on the network and available processing power in your LiveOS private cloud, you will be able to spin up simultaneous productions, and the same resource manager will prevent you from spinning up that one production too many that causes to hang the system. This is simply not possible in LiveOS. Now, if you want to keep on expanding your operations, you can keep on connecting different studio floors and different control rooms to the same LiveOS system. And if at any point you would run out of horsepower, you simply add media servers onto your centralized LiveOS setup. By that, the processing pool becomes a bit bigger. And that is how we helped this sports production company achieve their ambitions by lowering the cost per production and by increasing the volume of production. If you want to find out more about what we do, about LiveOS, about Matrox Monarch Edge, please get in touch with us, and I thank you for your attention.